So in lesson 2.6, we're going to be solving equations that have a coefficient next to the variable, meaning it has a number next to the variable. All right? And we're going to be using reciprocals to do this. So this is the first thing I want to review with you, is what a reciprocal is. Okay? The word reciprocal. What it refers to is a number that is multiplied by another number. A number that is multiplied by another number that gives you an answer of 1. Anytime you multiply two numbers and they equal 1, you are multiplying reciprocals. So, 2 times 1/2, for example. If you have 2 halves, how much do you have? You have 1, right? 2 halves equal 1. 2 times 1/2 is 1. Right? You can even picture that. 2 halves. 2 times 1/2. Those two numbers are then reciprocals because they equal 1 when you multiply them. Or a number times its reciprocal is equal to 1. Okay? What if you have 2/3? What's the reciprocal of 2/3? What number would give you 1? 2/3 times what? Times 3/2. So if we take a fraction and you flip it over, you get its what? You get its reciprocal, right? Yeah. When you take a fraction and you flip it over and you multiply them, you get 1. So the reciprocal is the fraction flipped over. Now, that's not the same as an opposite. Okay? Opposites are not reciprocals. All right? 5 and -5 are what? They're opposites. They're not reciprocals. So we're not going to use the negative amount or the opposite amount when we're solving this. Okay? We are going to use reciprocals. Like if we're starting with 5, we're going to use 1/5 to solve it. Or if we're starting with 1/5, we're going to use 5 to solve it, because those are reciprocals. 5 times 1/5 equals 1. So a reciprocal is a number that when you multiply it by the original number, it equals 1. Okay? So you might say, you might be given one like this, Allison.
But the reciprocal was the number before
The number before the variable? That's called a coefficient. I know these are terms that you kind of have to use, and you have to use over and over again in order to learn and to keep straight in your minds. Okay? Reciprocals are numbers that when you multiply them, they equal 1. So what you're going to have to do is find a reciprocal of a number. Okay? So, for example, if I were to erase this, think about it this way. What is the reciprocal of 2? A half. How do you know?
Because if you flip the half over, it's 2/1.
Right. If we write this as 2/1, we can easily find its reciprocal by putting the number diagonally across, or flipping that fraction over. Put the 2 down there, the 1 up there, for example. Okay? Okay?
So if you did like the reciprocal of 3, would it be a third?
Yes. the opposite of 3, or the reciprocal of 3 would be 1/3. Because 3 over 1 and 1 over 3 are flipped over. Okay? Reading.
That makes no sense. The reciprocal is not the opposite, but you use it as an opposite.
He's not using it as an opposite. Fraction.
But it's still the opposite.
In math, Brayden, opposites are positive and negative. The opposites in math are all, one is positive and one is negative. Okay?
He looks the exact same.
Well, these are both positive, aren't they? So they can't be opposites.
Yeah, but
In order for them to be opposites, one
makes
has
it
to be
opposite
positive.
of each
Just
other.
wait. In order for you to keep track of this, you can remember that one has to be positive and one has to be negative. Okay? And with reciprocals, look. With reciprocals, if one is negative, the other one also has to be negative because you have to get a positive 1. So how would you get a positive 1 with 2 negatives? Why do they both have to be negative? What is the rule there? What is the rule? Ethne? Okay, minus minus equals plus. Yep. Negative times negative is positive. Negative divided by negative is positive. Yep. So reciprocals have to have the same sign, don't they? They both have to be positive or they both have to be negative. Now, here's how we're going to use this. We're going to use this concept when we're solving equations like this. Let's say that we have 7m equals 35. Okay? 7m equals 35. So write down this example. We're going to solve this by multiplying both sides by this phrase, the reciprocal of the coefficient of the variable. Now, it's not that complicated, okay? It just sounds complicated, but it's really not complicated. All right? The reciprocal of the coefficient of the variable just means that we're going to use the reciprocal of 7, which is 1 over 7, to solve it. Okay? And with this type of equation, all we have to do is write 7 over 7 in order to use its reciprocal. Because 7 over 1 times 1 over 7 7 over 1 times 1 over 7 is simplified as 7 over 7, right? Which equals 1. Which then equals 1. And so we have 1m, and that's what we're trying to get to. When you use its reciprocal, you get 1m. Okay? And the most important rule of solving is always to do the same thing on both sides.
Oh, I see.
So if you write 35 over 7, you get the solution. 35 over 7 is 5. And you're proving it.
You should do the addition thing. You should decide what to do with that. No?
Yeah, and we get to this point, but in a different way, Tate.
Yeah, in a different way, but
Yep.
we use the same concept as adding and subtracting.
It's not a 1.
Yep.
Oh, I know how to check that.
How would you check that, Matt?
I know this is a crazy way, but I mean, I would do 7 minus 5.
Wait, 7 times.
Oh, well,
Right.
I had a different one. It was weird. It was like 7 minus 5 equals 2, and then take the number one from the top away. I know.
Okay, this means 7 times m. So when we put in the solution, we have to do 7 times 5.
Yeah.
And that will equal our
What do you give us for 35?
Okay? We use the original equation, 7m. All right? Let's go to our worksheet and practice this.
No, that was 1. So that makes me lose.
I'll come back to the notes, but I want to get us started on the worksheet, okay?
It's just confusing me when he's gonna start.
All right, so listen and follow along as best you can. So let's start with one like 6 times x equals 96. Jack?
Put the 6 in the box.
Right. So we use the reciprocal of 1/6 and make it 6 over 6. Because 6 over 6 is 1. And then put 6 on the other side. And do 96 divided by 6. Remember, this means division. 96 divided by 6, anyone? Yeah?
I wanna say 8. So I'm sure it's more like 9.
16.
16.
No.
I'm not good enough to know that in my head. So I'm going to check it with a calculator. 96 divided by 6. 16. Yep. Good. Yes, you can. Yep. Because the important point is not to be able to get the solution, but the important point of what you're learning how to do is to prove the solution using the rules of math. Okay? In this case, we're going to use reciprocals. So cross out reciprocals. When you're crossing out, what you're doing is showing that they factor into each other. Or 6 divided by 6 is 1. Okay? 6 goes into 6 one time. So we're crossing them out and reducing it to 1. And that proves that x equals 16. And then check. 16 times 6 should equal 96. And it does. I already checked it with my calculator. Oh, there's no box. Oh, there is a box in number 2, actually. Going across. There's a box. Yep. Start on the side with the variable, right? Andreas?
So you put 9 in below 9x.
Good.
Then you put 9 under 108.
Yep.
You divide it, which equals 12.
Good.
So x equals.
So x equals 12. And 9 times 12 is 108. Oops.
Wait, I did this
108.
Oh, you did 108 divided by 108?
Yep. Okay. Yeah. Now, here's what I want you to do for tomorrow. We're almost out of time. Do 3, 4, 5, and 6. Okay? I want you to skip 7, 8, 9, and 10 for today, for tomorrow. So we're going to come back to that one. But on the other side, I want you to do all of them. And I want you to write reciprocals for 1, 2, 3, and 4. See if you can find the reciprocal. So for the first one, what would the reciprocal of -6 be?
I know. 1 and -6.
1 over -6. Good. What would the reciprocal of 5/6 be? Andreas?
6 over 5.
Good. 6 over 5.
But wouldn't you add the n or anything like that?
Nope, you just have to write the reciprocal.
Check.
Well, but there's also a 5 in
What would you like?
And then do 5, 6, 7, 8, 9, and 10. You do those. So you're doing all of this page. And do 3, 4, 5, and 6. Okay? All right, here we go.